Hi, my name is Brianna Green, and I will be presenting on the skeletal system. So first I wanted to talk a little bit about how bones are technically considered organs because they contain more than one type of tissue. They're mostly made of osseous bone tissue, but they also contain cartilage, muscle, nervous, and epithelial tissue, which is why they're technically considered organs. Bones are made of active connective tissue that is constantly breaking down, regenerating, and repairing itself through its lifetime, which means that our skeletal system actually replaces itself every 7 to 10 years, which I thought was really cool. And bones not only supply the body with structure and support, but they also store calcium, phosphate, and other minerals. Bones are also important for hematopoiesis, which is blood cell production. All blood is generated through bone marrow, which helps store energy as fats. So, moving on, the average human has 206 bones in their body, and they are each categorized by two categories, the axial and the appendicular. So the first category, axial, includes 80 bones divided by the skull, the vertebral column, and the thoracic cage. These bones are foundational bones that provide most of the skeletal support and organ protection. And then appendicular bones, which is the other category, are bones that help us move around, including bones like your shoulder blades, your pelvis, and limbs that help us to move around every day. And so these two categories are also classified by shape, which there's long bones, short bones, flat bones, and irregular bones. So long bones are bones like your tibia and your fibula, and short bones are things like the talus in your foot. And then a flat bone would be considered like a thin bone, like your sternum. And then irregular bones would be something like, the weird shaped like pelvis and your vertebrae. And so all bones actually have a similar internal structure. So as you can see in this picture, it's like an inside look into the inside of a bone. So there's compact bone and there's spongy bone that is in one bone. Compact bone is a dense, smooth-looking external layer. So when you look at a skeleton or you buy a Halloween skeleton from the store, bones look smooth on the outside, but on the inside, that compact bone actually is around a porous, spongy-looking area. And spongy bone is actually tissue made up of trabeculi, which helps the bone resist stress and where bone marrow is stored. And so bone marrow, there are two kinds of bone marrow. There's red, which red bone marrow produces blood cells, so that's really important. And yellow bone marrow stores energy as fats. Bones are not solid and they have many layers to them of different plates and tunnels. So moving on to the next slide, we're going to talk about the basic structural units of bones. So there are these things called osteons, which are the basic structural units of bones. And osteons are cylinder structures that are parallel to the bone's axis, and they kind of look like tree trunks. So I've provided this picture here to kind of show you the inside of a bone, and it kind of looks like the rings in the tree trunks. And so within the tubes, or the tree trunks, I guess you would say, there are these things called lamellae, which are filled with collagen fibers. And this structure prevents torsion stress to the bone when getting twisted, which is why you can twist your ankle or go like this, and it prevents the torsion stress on your bones. And bones actually need nourishment, and there are canals that hold nerves and blood vessels, and between the lamellae layers, there's spaces called lacunae, and lacunae houses our osteocytes. So all of this is going on inside of our bones. These are mature bone cells that monitor and maintain bone matrix, which we've talked about in this class before. And so, like I've said, the lacunae houses our osteocytes, and our osteocytes, they communicate to our osteoblasts and our osteoclasts. And so, as you can see in this slide, we're talking about like the communication of the osteocytes. So osteoblasts are the bone makers, as people categorize them as, and osteoclasts are the bone breakers, which, like, obviously you're probably wondering, why are my own bones getting broken? But I'll explain that osteoblasts are they're bones that start out as cartilage, and the osteoblasts come in with collagen and enzymes that absorb calcium, phosphate, and other minerals from the blood. And then the minerals form a calcium phosphate, which crystallize and begin forming the bone. And so from the womb to 25 years old, our osteoblasts are consistently producing calcium phosphate until all of our bones are fully grown. And so on the other side, osteoclasts are the bone remodeling structure that when osteoclasts sense some type of stress or strain, osteoclasts come in and help fix that. They can detect things like small fractures. And so first what they do is release a chemical signal to the fractured bone. And then second, they begin like the secretion of collagen digesting enzymes in order to fix that. And this is where apoptosis begins, and apoptosis is basically like the self-destruction to the bone, like growing process, so that more damage isn't done to the bone, so the bone doesn't keep growing on like the damage that is done. And so osteoclasts signal the osteoblasts to come, and they begin repairing and rebuilding the bone. And that's how your bones keep fixing itself over time. And so one thing that we can prevent, like, the breaking of bones, is exercising. Exercising is super crucial to stimulate the bone remodeling and strength. And exercising not only builds muscle, but it actually builds bones too. And so that is my presentation for the skeletal system. Thank you.